Hi, my name is TagsDX with hopefully the only tutorial you will ever need to install Tensorflow to capture your own images and label them to build custom models with your own data. First, let's tackle some of the requirements you will need to have before starting this tutorial. Let's start by downloading JIT. Open a new browser and search JIT for Windows. Install it, and the next time you open a command prompt, you should have support for JIT commands. We will also be using Anaconda as a way of managing virtual environments. To get it, just open your browser Anaconda and download the latest version. You want to be sure it supports at least Python 3.8. Finally, you will need Visual Studio runtime files. The easiest way to get them is by installing Visual Studio 2017 Community Edition. Just locate the download. Sign in with your Microsoft account and install it. A reboot may be required after this step. With those three things taken care of, we can begin. Before we begin, I think a little disclaimer is in order. The following tutorial uses codes from Stack Overflow answers as well as Nicholas Renotte amazing guides for object detection using Tensorflow. It also borrows heavily from Paul Ingeniero. Both links to their channels will be on the description. If Nicholas wants me to take this down, I fully understand I will comply without questioning his intentions, as this tutorial clones his repository and makes fixes directly on his Jupyter notebook. The reason I'm doing this tutorial is because surfing on the comments I can see people struggling with the whole process. It's my intention to compile everything in a straightforward tutorial for those that want to follow the entire process. I will try to outline common mistakes and also try to tell you what each command does. Okay, disclaimer over. Open a new command prompt window. We will start by creating a new conda environment with the version of Python we want, in this case 3.8. With the command conda create -n tensorflow2 pip python equals 3.8. I will create a new directory on my D drive called tf for this tutorial. After that's ready, we will activate our new environment using activate tensorflow2. Here you can see me running a TensorFlow script to prove that this is a clean environment and doesn't have TensorFlow support. Next, we will install TensorFlow 2.70. In order for it to take care of the dependencies we will need later on, do this by running the command pip install tensorflow equals 2.70. Paste the following code to see if TensorFlow has been properly installed. You should see an output. Congratulations, your TensorFlow is correctly installed, but you lack GPU support. Let's fix that. Type in Google CUDA NVIDIA Toolkit and search for the official NVIDIA page. Go to Downloads and look for the CUDA Toolkit page. Do not download the first one. Instead, make your way to the archives and find CUDA 11.2. Select the version that better fits your system and download it to your work folder, in my case, TF. Now let's take care of QDNN. Type in Google QDNN download. Find the official NVIDIA page. To download QDNN, you will be prompted to create an account. Just create your account, then log in, agree with the terms and services, and once again make your way to the archives. Next, you will need to locate version 8.1. Select the correct version and save it to your work folder. Extract QDNN in its own folder and then install CUDA. Take the folders on the CUDA folder and match them with the install path for CUDA. Mine is Program Files NVIDIA Computing Toolkit 11.2. When you locate the directory that matches the folders, paste the files on your clipboard. Next, let's create some environment variables. If you're on Windows, right-click in the Windows icon on the bottom left, click System, scroll a bit and locate Advanced System Settings and Environment Variables. Scroll down on System Environment Variables until you find Path. Add the following path to your registry. Open a new command prompt. It won't work otherwise. Activate your environment and let's test it again. You should see your graphic card being recognized, and TF it's not working with CUDA Support. Next, let's install the object detection library for Tensorflow. First, let's clone the Tensorflow repository to your working folder. Follow the link and download Protobuf 3.14.0. Go down the page and select the one that fits your computer. Mine is Windows 64. Extract the files in your work folder. Add a system environment variable for those two folders in your Protos folder. Once again, you will have to close your command prompt for the change to take effect. Open a new command prompt, activate your environment, and go to your work folder. Enter the model and research folder in the Tensorflow repository you just cloned. Now comes the tricky part. Open Windows PowerShell by right-clicking on the Windows icon to bring up the Super User menu, and click on Windows PowerShell. If you don't have PowerShell, install it from the Windows Features menu. Just click on your Windows icon and type Features. Scroll until you see the Windows PowerShell and mark it. Click OK, and Windows will install Windows PowerShell. If you already have Windows PowerShell, navigate to your work folder, where Tensorflow was downloaded. Make your way to the research folders, Models, Research. The idea here is that we are compiling a bunch of protofiles into Python.py files that will be used by the object detection library. Next, we will paste this script on the Windows PowerShell, and you will see this process happening in real time at the left side of on screen. With that done, you can close that PowerShell windows now. We still have a few dependencies that we need to take care of. First, begin by installing Cython by running pip install Cython. Almost there, you will just need to install this last dependency. Let's install the PyCocotools by pasting this command. This command will not only clone the repository, but also install it with pip. Make your way to the Models, Research, Object Detection, Packages, TF2, and copy the setup.py file to your research folder. Finally, we will install Tensorflow from the repository by using the command python.m pip install dot. The dot is important, otherwise you will get this error. You have to remember, this is a clone of a live repository, so this will clone the last version of Tensorflow. So installing it this way will override your existing Tensorflow 2.70 installation. Almost there, one more last step. You will need to downgrade your installation of Tensorflow since you're now using version 2.90. Do this by running the command pip install -- upgrade tensorflow == 2.70. Don't be alarmed by the red text. It means there are incompatibilities in between the dependencies that are on the live repository versus the Tensorflow version you now have. You can test the model builder to see if you have object detection functionality by pasting this script. Congratulations, you now should have Tensorflow 2.70 support with CUDA. That's it for the installation of Tensorflow. Now let's create a new environment to work with Labelimg. As a rule of thumb, you don't want to use conda install commands after working with pip commands, so let's start by installing a new environment. Conda create -n Labelimg pip python = 3.8 and activate this new environment. Don't forget that when switching from environment to environment, you need to deactivate your main environment first. So deactivate the Tensorflow 2 environment to activate your new Labelimg environment. Labelimg would use the PyQt graphic interface. By the way, PyQt, it's called PyQt, so we will be installing PyQt dependencies. Type conda install pyqt = 5. We will also need to work with XML files, so do conda install lxml. Next, go back to your work folder. We will be cloning Labelimg repository there. Make your way to the Labelimg folder. We are going to compile the resources needed for it to work under Python using the built-in pyarcc5 program. The source file for this process is the resources.qrc file. Write the following command. This command will create a new file called resource.py on your lib folder. Run python labelimg.py. An error would happen. Let's restart that command prompt, activate your environment, and try again. There, you now have Labelimg. Close it and let's install OpenCV. And let's add some test code to capture images. In your command prompt with your Labelimg environment, do the following pip install command. You can test if OpenCV is correctly installed by typing Python followed by import cv2. If no error is shown, you're ready to work with OpenCV. Exit the Python console by typing quit open parentheses and close parentheses. Finally, we need to install Jupyter to be able to work with a notebook under our environment. Type pip install Jupyter. Although Jupyter is not strictly necessary, it provides a friendly environment to work on. Jupyter takes its root folder as the directory it was launched on, so I'd recommend you to go back to your work folder. Open it by typing Jupyter Notebook. This will create a web server for your notebooks. Create a new notebook and select your kernel. Paste the script in the description of the video. This will be your image capture app. It will take a picture every time you press the spacebar. To execute a cell in a Jupyter notebook, you have to press Shift and Enter. A Windows will open, but it will not take focus. Finally, you can create your own custom dataset. I'll be using a honey bottle and a Mac. You can see the images being created on the left side of the screen. You can exit the program by pressing the escape key anytime you want. You will need to create a test and train folder and put half of the images in each folder. Remember to split the images for both objects that you're intending to classify. You can now close that Jupyter notebook. The command prompt will be busy with this web server for the notebook, so you can close it by using Ctrl+C. Now that enough data has been collected, let's label those images. Navigate to your Labelimg path and run Labelimg with Python labelimg.py. Select the folders where you save the pictures. In my case, I'm working directly on my work folder. This is a bad idea, as you will see later on. It's better to first split the images in the respective test and train folders, as you will have more control of where the XML files will be created. Hotkeys for working with Labelimg are as follows: W to create a new region, A and D to go back or advance to the next picture, and Ctrl S to save. A good rule of thumb is labeling each object on different passes. Don't forget to label the images using Ctrl S, save the new XML file, and advance to the next picture. You want to keep your regions as tight as possible. Remember to label every object with its own tag. In my case, the tags are honey and mag, both lowercase. This process is a bit time consuming, but keep going until you reach your last image. In my case, I still have to split the files, but hopefully you have done it beforehand. Remember that each XLM file has to correspond to the picture that it's linked to. In my case, I had a bunch of errors where images were present but not its XLM file, so try not to do what I did in this example, and just label every image under test and train folder. Remember to change the directory when labeling though. We are done with OpenCV and Labelimg. Let's go back to your Tensorflow 2 environment and make your way to your work folder. We will be cloning Nicholas Renotte amazing workflow notebook. Links to his tutorial will be on the description along with following his channel. I just wanted to compile this info in a single video that works without much hassle. To clone his repository, let's do a git clone command. Yeah, I'm not typing that, so I will rename his folder to RTOD. Please be mindful of the environment you are working on. Also, remember you haven't installed Jupyter yet in this environment, so let's do it now. Pip install Jupyter. If you don't do this, there is a high chance of Jupyter actually running, but not organizing any of the dependencies you need for the Tensorflow program to work. Here you can see how I have a 6 XML file but no picture to link on. That's why I'll recommend you to work on separate folders when labeling the images. I left a bit of my struggle, so you can see how to fix it if it ever happened to you. I just put each folder side to side and see what pictures and XML files were missing. Finally, and with that out of the way, we can copy our test and train folders and paste them in workspace, images, test and train folder respectively. Next, go back to your work folder and copy the Tensorflow models to RTOD, Tensorflow, and paste them so it can be accessed by the program. Go back to our RTOD folder and locate Nicholas Notebook. Please make sure you have an activated environment for your Tensorflow 2 and you are on the RTOD folder and run Jupyter Notebook. Open Nicholas tutorial. You can delete or comment the first line of the notebook. Be aware that Nicholas has inbuilt support for batch commands, so that will not work for the majority of people. Also, let's change the name of the objects to reflect your own data. Make your way to the directory where you saved your images and try opening up an XLM file with your notepad. You will see a tag called name. Make sure that in step 1 the labels variable has the same names as your tags. I will clear the outputs so you can see this happening in real time. The notebook by default tries to clone the repository for Tensorflow once again, but we already did this in a previous step, so just comment this line. Also, if you don't have access to batch commands, the cp command is not going to work, so comment that line and let's copy the file on our own. Before we do that though, let's fix some of the more notable problems that the notebook has. In the OpenCV program at the bottom, you will see a cap release call. You can get rid of it by pressing D 2 times on your keyboard. Also, get rid of the 2 lines at the bottom. We are going to be stepping through the notebook, but if you want to see it happening in real time, I'll recommend you to go to workspace annotations, so you can see what's happening when you execute each cell. Go to the top part and start Shift-Enter your way to the program. The create TF record step will take a while, so be patient. You can see it's working because the number is replaced by an asterisk. This is the data we'll use to train your model. Keep stepping through the code until you reach the copy model config to training folder. I told you before, the batch command is not going to work by default, so make your way through workspace, pre-train models, and copy the pipeline config to your own model, my SSD MovNet folder. Once that's done, you can keep stepping through the code. The next step will configure the model for the training process. Keep stepping through the code until you get a string of text. This will be the command we will be using to train the model. So copy this command. Since Jupyter Notebook has hijacked your window, open a new command prompt, activate your environment, and make your way to your work folder. You will be executing this command from the same directory of the Jupyter Notebook, otherwise it won't work. You will most likely find this error and CUDA will not be used to train your model, so press Ctrl C to cancel this output. And let's fix your CUDA problem. To fix this error, we will be tricking CUDA. Make your way towards your program files, NVIDIA GPU Toolkit, and the version of CUDA you have installed, in this case 11.2. In your bin directory, copy your CUDA64-110 file and put it on an empty folder. Rename this file to CUDA64_101.dll and put it back on the bin folder. Okay, let's try running the command again. This time it should work and it will recognize your GPU card. If you want to see the training happen in real time, go to your Tensorflow workspace models, my SSD MovNet. There you will find the model data as it's being created. When you reach this screen, you will know your model is being trained by your custom dataset. The time and accuracy it takes to train your model will depend on the amount of steps, the quality of your data, and the type of pre-trained model you are using. For more info on this, I will recommend to watch more of Nicholas' tutorials. The model will stop training as soon as it reaches checkpoint 6 or 5000 steps. Before we execute the code though, we have to add a little line after cap release. Add cv2.destroy all windows, open and close parentheses. This will prevent the program from hanging when trying to exit the program using the queue. Go back to your notebook and step through the code from the 7th step. And that's it for me. If you have any problem in the process, type it on the comments and I will try to address them. If the video was helpful for you, please give it a like and I'll see you in the next one. I've been HDX and have a great one.